The two most common terms used in the assessment of granular material to be used in water and wastewater filtration are effective size and uniformity coefficient. When we've completed our sieve analysis and we've entered the data into an Excel spreadsheet, we look at the grams or percent of material retained on each sieve stack, and from that we can determine the effective size. Effective size is determined by the D10 value. That is the screen in the sieve stack that passes only 10% of the sample, or inversely retains 90% of the sample. The D10 value is really telling us what the smallest fraction of the sieve analysis is. So in the sample on the right actually has a D10 value of 0.655 millimeters. So by conventional rounding, we would call that a 0.7 millimeter effective size, even though it does skew a little bit smaller than the sample on the left. The D10 value is a very limited amount of information and does not tell us everything we need to know about the sample. I would argue that the uniformity coefficient is a much more telling piece of information. In order to determine the uniformity coefficient, we need a second piece of information. We need the D60 value. The D60 value for the sample on the right is actually 0.9 millimeters. The D60 value for the sample on the left is 1.5 millimeters. For the sample on the right, if we take the D10 value of 0.6 millimeters and we divide that into the D60 value of 0.9 millimeters, we get a uniformity coefficient of 1.5. With the sample on the left, if we take the D10 value of 0.7 millimeters and we divide that into the D60 value of 1.5 millimeters, we get the 2.1 uniformity coefficient. As you can tell by looking at these samples, they're very different even though the effective size is the same. The sample on the right has very little large material. The sample on the left has quite a bit large material. Uniformity coefficient helps us identify samples that have a disproportionately large amount of oversized material. This is important in water and wastewater because it's the uniformity coefficient that most impacts our backwash requirements. Remember that it's the largest fraction of material in a filter that is the hardest to fluidize. Or, another way to say it is, the fluidization velocity required to backwash a granular filter media is determined by the largest particles in that filter bed. Based on the samples in front of us, the material on the left, which has material as large as 2.3 millimeters, would take significantly greater backwash flow velocity than the sample on the right in order to fluidize effectively. The D60 value is the sieve that passes 60% of the material. There's still a significant amount of material larger than the D60 value. At Wateropolis, we also look at the D90 value. The D90 value for the sample on the right is 1.2 millimeters. The D90 value for the sample on the left is 2 millimeters, almost twice the size. We think that the D90 value is a more appropriate way to assess filter media because that's the value that's going to drive the fluidization requirements of a filter. And it is usually overlooked by vendors in this market space. Some things to keep in mind. Make sure that the vendor of granular material is using a set of consecutive sieves without significant gaps in sieve size. The closer the sieve value from screen to screen, the more accurate the sieve analysis. Lowering the uniformity coefficient reduces the size variation of the granular mixture by scalping out the larger grain material. This elimination of larger grain content lowers the average grain size in the bed overall. This reduces backwash rates but can have a negative impact on the cost of production. Thank you, and we'll see you next time. I hope you enjoyed the video.